Welcome, YouTubers, to another episode in my Grammar Hero series. In today's video, I'm going to be discussing everything you need to know about triangles in order to do well on the mathematics knowledge, as well as the arithmetic reasoning subtest of the Armed Services Vocational Aptitude Battery, that is the ASVAB, as well as the pre-screening Internet-delivered computer adaptive test, that is the PiCAT. More specifically, I'm going to break this video down into two main parts. In the first part of this video, I'm going to talk about how to classify triangles, the Triangle Sum Theorem, how to find the area of triangles, the Pythagorean Theorem, and the Triangle Inequality Theorem. While I talk about each of those topics, I'm also going to work out 14 very easy practice questions. In the second part of this video, I'm simply going to work out 4 questions that should closely mirror, more or less, what you may see on the actual ASVAB or PiCAT. As always, to get the most out of this video, you'll want to pause the video after I read a practice question, attempt to work out the practice question on your own, and then resume playing the video to check your solution. As a reminder, you're not permitted to use a calculator or a reference sheet on the actual ASVAB or PiCAT, so try not to use those resources as you work your way through this video. Finally, I want to say this. I'm going to include timestamps in the description of this video. You're more than welcome to use those timestamps to skip ahead to the practice questions in this video. So all that being said, let's go ahead and get started with today's video. Not surprisingly, we're going to start today's video by working on classifying triangles by their side lengths, as well as by the measure of their angles. And let me say this, believe it or not, something as simple as this can actually show up on the ASVAB or PiCAT. So with that in mind, let's take a look at these definitions here. I'm going to start by talking about how to classify triangles by their side lengths. And as you can see, there's 3 definitions you should be familiar with. Notably, an equilateral triangle has 3 equal sides. And if you take a look right here, you can see that this side is equal to this side, and that side's equal to that side. That is to say, all 3 sides of this triangle are equal. Next, you can see that an isosceles triangle has 2 equal sides, and these hash marks indicate that this side is equal to this side. And finally, a scalene triangle is a triangle in which none of its sides are equal. And you can see there are no hash marks on any of these sides. That indicates that none of the sides are equal. Now that we've taken a look at how to classify triangles by their sides, let's talk about how to classify triangles by their angles. As you can see, an acute triangle is one in which all 3 of its angles are less than 90 degrees. A right triangle is one in which one of the angles is exactly 90 degrees. Of course, more often than not, you'll see this symbol indicating that one of the angles is 90 degrees. And finally, an obtuse triangle is one in which one of the angles is greater than 90 degrees. And clearly we can see that this angle right here is almost certainly greater than 90 degrees. All right, so let's just work on some simple practice problems to make sure we understand how to classify triangles. Number 1 says a triangle with sides of all different lengths is called A, an isosceles triangle, B, a scalene triangle, C, an equilateral triangle, D, none of these. As you may recall, a scalene triangle is one that does not have any equal sides. So the answer to this one is B. Number 2 says a triangle in which one of the angles is greater than 90 degrees is called. You should know that a triangle with an angle that's greater than 90 degrees is called an obtuse triangle. And of course, you can see that definition right here. An obtuse triangle has one angle greater than 90 degrees. And finally, number 3 says a triangle with side lengths of 7 inches, 8 inches, and 8 inches. Well, let's think about this. We have side lengths of 8, 8, and 7. These 2 side lengths are equal. So a triangle that has 2 equal side lengths, as you may recall, is called an isosceles triangle. And we can see that definition right here. An isosceles triangle has two equal sides, which is exactly what this question said. So now that we've discussed how to classify triangles, let's talk about the triangle sum theorem. And as you can see, it says this: the sum of the three interior angles in a triangle is always 180 degrees. Specifically, the measure of angle A plus the measure of angle B plus the measure of angle C in a triangle is always going to equal 180 degrees. Let me point something out here. If you're given at least two of these measurements, you can always find the third one. So if you're given A and B, you can find C. If you're given A and C, you can find B. And if you're given B and C, you can find A. And as a matter of fact, that's what we're going to see in the following practice questions. So with the triangle sum theorem in mind, let's take a look at a few questions here. As you can see, number one says, find the measure of the third angle of a triangle if the measures of the other two angles are 45 degrees and 45 degrees. Again, according to the triangle sum theorem, all the angles in a triangle are going to add up to 180 degrees. In other words, measure of angle A plus the measure of angle B plus the measure of angle C is always going to equal 180 degrees. In this case, we know what two of these angles are. Let's call this one angle A, and let's call this one angle B. And that means ultimately we're going to be figuring out how many degrees angle C is. So let's just go ahead and plug these values in. This becomes 45 plus 45 plus the measure of angle C, which is what we're trying to figure out, has to equal 180 degrees. Well, 45 plus 45 is 90. If you can't do that in your head, you can always work it off to the side the old-fashioned way here. 5 plus 5 is 10, so drop down to 0, carry a 1. 4 plus 4 is 8, plus 1 is 9. So this becomes 90 plus the measure of angle C equals 180 degrees. And again, to figure out the measure of angle C, we're going to be solving for C. So let's go ahead and subtract 90 from both sides. This crosses out here, leaving you with the measure of angle C. Can't do this in your head. You can always work it off to the side. This is 180 minus 90. 0 minus 0 is 0. 8 minus 9 we can't do, so we're going to have to borrow. This will become 0. This will become 18. 18 minus 9 is going to be 9. So the measure of angle C is 90 degrees. And that tells us that the third angle is 90 degrees. And we found that using the triangle sum theorem. All right, so let's take a look at number 2 here. It says if triangle ABC is such that angle A equals 38 degrees and angle B is 134 degrees, then calculate angle C. Again, according to the triangle sum theorem, all of the angles in a triangle are going to add up to 180 degrees. That is to say, the measure of angle A plus the measure of angle B plus the measure of angle C is going to be 180. And in this case, we were told what A and B were, so let's plug those in accordingly. Again, we know A is 38, B is 134. We're trying to figure out what the measure of angle C is, and of course, we know the sum of these three has to equal 180 degrees. Let's go ahead and add 134 and 38 together the old-fashioned way here, so we don't make any mistakes. 4 plus 8, that's 8, 9, 10, 11, 12, so drop down a 2, carry a 1. 3 plus 3 is going to be 6, plus 1 is 7, and drop down this 1. So this becomes 172 plus the measure of angle C equals 180. Now we're solving for C, so let's subtract 172 from both sides. This crosses out here, leaving you with the measure of angle C. And you should be able to do this in your head. 180 minus 172 is going to be 8. So now that we've talked about the triangle sum theorem, let's talk about calculating the area of a triangle. As you can see, to calculate the area of a triangle, we're going to do 1/2 times the base of the triangle times the height of the triangle. That is, area equals 1/2 base times height. The only thing that's important to point out here is this. As we know, triangles come in different shapes and sizes, and you have to be mindful of the fact that your height is always going to be from the apex, or the tallest point in the triangle, straight down. So right here is the apex of this right triangle, and so the height of this triangle is going to be from here to here. In this triangle here, the apex, or the highest point in the triangle, is here. So the height goes from the apex straight down. And in this triangle here, the apex of this triangle is right here. And the height, therefore, goes straight down. So with those things in mind, let's take a look at a few practice problems here. Number 1 here says, find the area of a triangle that has a base of 14 inches and a height of 10 inches. As we should know now, to calculate the area of a triangle, we're going to do area equals 1/2 base times height. And thankfully enough, this problem gave us both the base and height of this triangle. Notably, it told us B, or its base, is 14, and H, or its height, is 10. So all we have to do is plug those two values into this formula and simplify accordingly. This becomes area equals 1/2, base is going to be 14, height is going to be 10. So let's work on simplifying this. 1/2 of 14. 1/2 times 14 is 7. Now, in the event you can't work that out mentally, let me go ahead and work it off to the side. We have 1/2 times 14. That is to say, we're multiplying a fraction, 1/2, by 14, a whole number. To proceed, we want to rewrite 14 as a fraction by placing it over 1. And now that we've done that, we're simply multiplying two fractions here, which means we're just going to multiply straight across. 1 times 14 is 14. 2 times 1 is 2. 14 divided by 2 is 7. So that's how I got 7 there. Of course, we have this 10 off to the side there. So now, to find the area, you can see we have to do 7 times 10, which is going to be 70. So the area of this triangle is 70 inches squared. Of course, one thing I want to point out is that whenever you're talking about area, your units are going to be squared. So 70 inches squared. Let's take a look at number 2 now. Number 2, as you can see, says if the area of a triangle is 48 square inches and its height is 16 inches, how long is its base? So we're going to be using the same formula to calculate the area of a triangle, notably area equals 1/2 base times height. Of course, for this problem, you can see that we were given A, our area. We were told that the area of this triangle is 48 square inches. We know its height, our H, is 16. And we know that we're going to be trying to figure out how long its base is, or B. All right, so let's go ahead and plug those things in. We know A is 48, so this becomes 48 equals 1/2. We don't know what B is, so we'll leave that as is. And we know this triangle has a height of 16, so this is times 16. So some people might get stuck right here because this says 1/2 times B times 16. And one thing you should realize is that you can take this 1/2 and multiply it by 16 here. What is 1/2 of 16? That's 8. So this becomes 8b. So 48 equals 8b. And again, in case you can't work that out mentally, let me show you how to do it off to the side here. We have 1/2 times 16. As we saw previously, when we multiply a fraction by a whole number, we want to rewrite that whole number as a fraction by placing it over 1. Then we multiply straight across. This becomes 16 times 1, which is 16. 2 times 1, which is 2. 16 divided by 2 is 8. So that's how I came up with 8 there. Now we're going to be solving for b, so let's divide both sides by 8 to get b by itself. This crosses out here, leaving you with b on this side. 48 divided by 8, that's a times table. That's going to be 6. So b in this case is going to be 6 inches. In other words, if this triangle has an area of 48 square inches and a height of 16 inches, the length of its base is going to be 6 inches. So now that we've talked about how to calculate the area of a triangle, let's talk about the Pythagorean theorem. And the Pythagorean theorem is specifically in regard to right triangles only. Again, right triangles have one angle that measures exactly 90 degrees. And the Pythagorean theorem says this: in any right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. That is, a squared plus b squared equals c squared. So again, the sum of the squares of the legs of the triangle is equal to the square of the hypotenuse. And the formula you have to be familiar with for the ASVAB is this: a squared, that's one of the legs of a right triangle, and you can see that that's here, plus b squared, that's another leg of the right triangle, and that's right here, equals c squared, where c is the hypotenuse of the right triangle. How do you identify the hypotenuse of the right triangle? The hypotenuse in a right triangle is always going to be directly across from the right angle. All right, so with that in mind, let's take a look at a few simple practice problems here. All right, so number 1 says, how long is the hypotenuse of a right triangle, given that its legs measure 6 inches and 8 inches? So let's go ahead and quickly sketch a right triangle. It's usually helpful to make sketches when you're dealing with triangles, especially right triangles. And let's put this symbol to indicate that this is our right triangle. Again, how do we identify the hypotenuse? That's always going to be directly across from our right angle. So from here to here is our hypotenuse. C always refers to the length of our hypotenuse. So we know this side is C. And of course, if this side's C, that means that this side's going to be A and this side's going to be B. And we're told that this triangle has legs that measure 6 inches and 8 inches. So we can let A be 6 and B be 8. And we can now use the Pythagorean theorem to figure out what C is. Again, Pythagorean theorem says A squared plus B squared equals C squared. We now know what A and B are. That was given to us in the problem. So in place of A here, I'm going to put 6. This becomes 6 squared plus B, which is 8. 8 squared equals C squared. What is 6 squared? That's 36. What is 8 squared? That is 64 equals C squared. If you can't do this in math in your head, let's work it off to the side. We have 64 plus 36. 4 plus 6 is 10, so bring down a 0, carry a 1. 3 plus 6 is 9, plus 1 is 10. So this is 100 equals C squared. Again, we want to figure out what the length of this hypotenuse is, which is just C. We have C squared here. So to get rid of this square, we're going to take the square root of both sides. And in doing so, that's going to cross out this square here and leave us with just C. What is the square root of 100? That is 10. So as we can see, C is 10. In other words, how long is the hypotenuse of this right triangle? It's right here. It's 10 inches. And we found that using the Pythagorean theorem. Let's take a look at another example here. How long is the hypotenuse of a right triangle, given that its legs measure 5 inches and 9 inches? So let's quickly make a sketch of a right triangle. And let's put our symbol to indicate that this is our right angle. Of course, our hypotenuse, our C, is always going to be directly across from the right angle. So this is going to be C. And we can let this side be A and this side be B. Again, according to the Pythagorean theorem, A squared plus B squared, that is the legs of the triangle, have to equal C squared. Well, we know what the legs of the triangle are. We're told that they are 5 inches and 9 inches. So we can say this is 9 and this is 5. And it doesn't matter how you label these. I could have said this is 5 and this is 9. That's irrelevant at this point. All right, so let's plug those values in accordingly. This becomes 9 squared plus 5 squared equals c squared. 9 squared is 81. 5 squared is 25 equals c squared. Let's add these together off to the side so as not to make any mistakes here. 81 plus 25. 5 plus 1 is 6. 8 plus 2 is 10. So this is 106 equals c squared. Again, we want to know how long the hypotenuse is, which is c, not c squared. So we're going to have to take the square root of both sides to figure that out. This crosses out here, leaving you with c. And as it happens, we can't simplify this any further. 106 has two factors, notably 53 and 2. So this is going to be c equals the square root of 106. And in math, it's customary to write the value for which you solved on the left. So this is c equals 106. All right, so that's that one. Let's take a look at a third example here. It says if a right triangle's leg is 9 and its hypotenuse is 15, what is the other leg's length? And there was an apostrophe there. So let's go ahead and quickly sketch a right triangle here. And there's our right triangle indicator, which means that this side is going to be our hypotenuse, and we know that's going to be C. And that means that this is going to be A, and this could be B. Well, let's reread this problem. If a right triangle's leg is 9, so we know one of its legs is 9, so we'll let B be 9. And its hypotenuse is 15, so C in this case is going to be 15. What is the other leg's length? So in this case, we don't know what A is. So we're going to be solving for A ultimately. And we're going to use the Pythagorean theorem to do that. Again, A squared plus B squared equals C squared. We don't know what A is. So we're going to leave that as A squared plus B squared. Well, B is 9, so this is 9 squared equals C squared. C is 15, so this is 15 squared. This becomes A squared plus 81. Again, 9 squared is the same as 9 times 9, which is 81, equals 15 squared. 15 squared is 225. That said, if you couldn't work that out, you should know that 15 squared is the same thing as 15 times 15. And you can work that out the old-fashioned way if you need to. 15 times 15. 5 times 5, of course, is 25, so drop down to 5, carry a 2. 1 times 5 is 5 plus 2 is 7. Before we start multiplication with this 1, we have to bring in a 0 placeholder. 1 times 5 is 5. 1 times 1 is 1. Let's add these together now. 0 plus 5 is 5. 7 plus 5 is 12. Carry a 1. 1 plus 1 is 2. So that's how I got 225. All right, so again, we're going to be solving for A squared. So let's subtract 81 from both sides now. This crosses out here, leaving you with just A squared on this side. And so as not to make any mistakes, let's go ahead and work this off to the side. We have 225 minus 81. 5 minus 1 is going to be 4. 2 minus 8 we can't do, so we have to borrow. This becomes 1. This becomes 12. 12 minus 8 is 4. 1 minus nothing is 1. So this is A squared equals 144. Let's take the square root of both sides to get just A by itself. This crosses out here, leaving you with A. What is the square root of 144? That's going to be 12. So we know that A, or the length of the other leg in this right triangle, is going to be 12. All right, so that is the Pythagorean theorem. So the Triangle Inequality Theorem is the last thing we're going to talk about before we move on to the practice questions that should more or less closely mirror what you'll see on the ASVAB or PiCAT. And it says this: the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if I have a triangle that looks like this, for example, and I call this side length A, this side length B, and this side length C, the Triangle Inequality Theorem says this: for this to be a triangle, side length A plus side length B has to be greater than side length C. Likewise, side length A plus side length C has to be greater than side length B. And side length B plus side length C has to be greater than side length A. So with that in mind, let's go ahead and look at a few practice questions here. So this first question, as you can see, says, can a triangle have lengths of 2, 4, and 7? And we're going to use the Triangle Inequality Theorem to figure this out. And if it's helpful, you can quickly make a sketch. Again, we're working with the triangle here. And let's say this side's A, this side's B, and this side's C. Let's let A correspond to 2, B correspond to 4, and C correspond to 7. So A is 2, B is 4, and C is 7. According to the Triangle Inequality Theorem, the sum of two sides must be greater than the third side. That is, A plus B has to be greater than C. And let's see if this is true for this triangle. What is A? A is 2, B is 4, and what is C? C is 7. 2 plus 4 is 6. Is 6 greater than 7? It is not. In other words, the sum of side length A and the sum of side length B is only 6, which is less than the third side, which means that according to the Triangle Inequality Theorem, this cannot be a triangle. So number 2 says, can a triangle have lengths of 4, 7, and 9? Of course, we can use the Triangle Inequality Theorem to determine if it can. So let's quickly draw a triangle here. And it really doesn't matter what it looks like in this case, as long as we say that this side's A, this side's B, and this side's C. According to the Triangle Inequality Theorem, two sides of a triangle, the sum of two sides of a triangle, have to be greater than the third side of a triangle. In other words, A plus B has to be greater than C. A plus C has to be greater than B. And B plus C has to be greater than A. If these three conditions are met, then you have a triangle. If any of these conditions fail, you do not have a triangle. So let's go ahead and label these accordingly. Let's call A 4, B 7, and C 9. So A is 4, B is 7, and C is 9. So let's check these conditions, and I'm going to separate these with bars so it's a little bit easier to see. What is A? It's 4. What is B? It's 7. And what is C? It's 9. Well, what is 4 plus 7? That's 7, 8, 9, 10, 11. Is 11 greater than 9? It is. This is a true statement. So we've passed this test right here. What about A plus C? Well, A is 4. C is 9. And what is B? B is 7. What's 4 plus 9? It's 13. Is 13 greater than 7? It is. This is a true statement. So we know that this passes the test. And let's take a look at B plus C. B is 7. C is 9. And is that greater than A or 4? 7 plus 9 is 16. 16 is in fact greater than 4. So that's also a true statement. Given that all three of these statements are true, we know that we do in fact have a triangle. So yes, these side lengths can make a triangle, given that they pass these little tests according to the Triangle Inequality Theorem. So number 3 says two sides of a triangle are 20 and 32. Which of the following cannot be the third side of this triangle? Of course, we now know that we can use the Triangle Inequality Theorem to figure this out. And that says this: if you have a triangle, the sum of two sides have to be longer than the third side. And of course, we can label this A, B, and C. And that looks like this. A plus B, that is the sum of side A and side B, has to be greater than side C. A plus C has to be greater than B. And finally, B plus C has to be greater than A. In other words, if all these conditions are met, then we know that we have a triangle. With that said, in this case, we're trying to figure out which of these cannot be the third side. So in light of that, let's start by labeling A as 20 and B as 32. That means as we run our test, C is going to be 10, C is going to be 13, C is going to be 15, and C is going to be 17 until we figure out which of these does not work. So with that in mind, let's go ahead and label our triangle. First, we're going to let A be 20, B be 32, and C be 10. Let's go ahead and run our test. A plus B, well, that's going to be 20 plus 32, has to be greater than 10. 20 plus 32 is 52. Is 52 greater than 10? Of course it is, so that works there. What about A plus C? This is 20 plus 10. That has to be, according to the Triangle Inequality Theorem, greater than B, which is 32. 20 plus 10 is 30. And is 30 greater than 32? It's not. So right here, this tells me that 10 cannot be the third side length of this triangle since it fails the Triangle Inequality Theorem. All right, so that's that one. All right, so number 4, as you can see, this says the triangle has side lengths of 5, 7, and x. Which of the following cannot be a value of x? Of course, we're going to use the Triangle Inequality Theorem to figure this one out. So we're going to have a triangle here. And according to the Triangle Inequality Theorem, the sum of two lengths of a triangle have to be greater than the third length. And of course, we can label this A, B, and C. And we're only going to use the first test here. We're going to say A plus B has to be greater than C. And let's think about why. I'm going to let A be 5, B be 7, and I'm going to let X be C. So this is 5, 7, and C is X. So in other words, we just have to find a value of C such that we fail to satisfy the requirements of the Triangle Inequality Theorem. So this becomes 5 plus 7 is greater than. And what are we going to plug in for C here? Well, we're going to test all of our answer choices right here. We're going to test 10. Then after that, we're going to test 13. After that, we're going to test 5 plus 7 is greater than 7. And then we're going to test 5 plus 7 is greater than 5. And whichever one of these fails, we'll know cannot be a value of x. So let's go ahead and get started. 5 plus 7, that's 7, 8, 9, 10, 11, 12. Is 12 greater than 10? It is. So it passes. 5 plus 7 is 12. Is 12 greater than 13? It is not. Therefore, we know 13 is not a possible value of x. All right, so that is that one. Now that we've looked at some properties of triangles and discussed those formulas and theorems, let's take a look at some challenging practice questions that should more or less mirror what you'll see on the PiCAT or ASVAB. So number 1 says a rectangle has a length of 12 inches and a width of 5 inches. What is the diagonal of the rectangle? So you might be saying to yourself, how am I going to figure out what this is using my knowledge of triangles? Well, let's make a sketch here. First, let's sketch a rectangle since we know that's what we're dealing with. And you should know some properties of rectangles. Notably, this length of this rectangle is the same as this length, and this width of the rectangle is the same as this width. So according to the problem, this is 12, which means that this is 12. This is 5, which means that this is 5. And we want to know, what is the diagonal of the rectangle? Well, a diagonal of a rectangle basically means you cut it in half from here to here. And when you do that, what you get is a pair of right triangles. As a matter of fact, I can go ahead and pull one of those right triangles off to the side here. So we know this is 5 and this is 12. Well, here's our right angle. And we know that right across from our right angle is our hypotenuse, or C. In other words, if we figure out what C is here, we'll know the length of this diagonal in this rectangle. And how can we figure out what C is, the hypotenuse? Well, we can use the Pythagorean theorem. And the Pythagorean theorem says this: a squared plus b squared has to equal c squared, where a and b are the legs of the right triangle, and c is the hypotenuse of the right triangle. So we're going to be solving the Pythagorean theorem for c. We're going to let this be a and this be b. So this becomes 12 squared plus 5 squared equals c squared. 12 squared, of course, is the same as 12 times 12, which is 144. 5 squared is 5 times 5, which is 25, equals c squared. So as not to make any mistakes here, I'm going to add these off to the side. 144 plus 25. 4 plus 5 is 9. 4 plus 2 is going to be 6. And 1 plus nothing is 1. So this is 169 equals c squared. We want to get c by itself, not c squared, so we're going to take the square root of both sides. This will cross out this square here, leaving us with just c on this side. What is the square root of 169? It's on my reference sheet on my website. It's 13. So c in this case is 13. Since c is 13, we know the length of this diagonal is also 13 inches. All right, so the answer to this one is 13. All right, so number 2 here says, in a triangle, if the second angle is 2 times the first angle and the third angle is 3 times the first angle, find the angles of the triangle. Well, we can use the Triangle Sum Theorem to figure this one out. Again, according to the Triangle Sum Theorem, angle 1 plus angle 2 plus angle 3 in a triangle are always going to add up to 180 degrees. And let's make a sketch in this case to try to figure out what's going on in number 2. So we have our triangle here. And it seems to me that both angle 2 and angle 3 reference angle 1. It says the second angle is 2 times the first angle, and the third angle is 3 times the first angle. And we don't know any of those values. So I'm going to let angle 1 be x. And let's go from there. If the second angle is 2 times the first angle, well, if the first angle is x, that means the second angle is 2x. Similarly, if the third angle is 3 times the first angle, that means that if the first angle is x, the third angle is going to be 3x. So here's angle 1, here's angle 2, here's angle 3. Now let's plug those values into the Triangle Sum Theorem here. This becomes x plus 2x plus 3x equals 180. All these are like terms, so we can combine them. X plus 2x is 3x. 3x plus 3x is going to be 6x equals 180. Now let's divide both sides by 6 to get x by itself. This crosses out here, leaving us with just x. And you should be able to do this in your head. How many times does 6 go into 18? Well, that's going to be 3 times, and then just drop down that 0. So in other words, 180 divided by 6 is 30. I'll do this the long way if you need to see it. This says 180 divided by 6. 6 doesn't go to 1. 6 goes into 18 3 times, but that said 6 goes into 180 30 times. 30 times 6 is 180. 180 minus 180 is 0. All right. Now we had to find all the angles of this triangle, and we can see those are right here. Angle 1 is x, angle 2 is 2x, and angle 3 is 3x. So angle 1 is equal to x, and we know x is 30, so angle 1 is 30 degrees. Angle 2 is 2x, and we know x is 30, so this becomes 2 times 30, which is 60 degrees. And then finally, angle 3, we can see is 3x. We know x is now 30, so this becomes 3 times 30, which is 90 degrees. All right, so those are our angle measures, 30, 60, and 90. And that is that one. So number 3 says the base of a triangle is 6 inches more than its height. If the area of a triangle is 36 square inches, what is the height of the triangle? So it should be pretty clear that at some point we're going to have to use the area formula to figure this one out. And to find the area of a triangle, it's 1/2 base times height. So let's go ahead and just jot that down from the get-go. And this problem's a little bit challenging because you also have to think about this problem both visually as well as algebraically. So let's start by thinking about this problem visually. Visually, we're dealing with a triangle. And as it happens, I'm going to make a right triangle since I think those are pretty easy to deal with. Here's the height of my right triangle, and here's the base of my right triangle. That is, this side length is our height, and this side length is our base. Well, what's this problem say? It says the base of the triangle is 6 inches more than its height. So we don't know how high this triangle is, so it's going to be x inches high, and that means its base is going to be x plus 6 inches long. All right. So we've taken care of the visual part as well as the algebraic part. Let's go ahead and try to solve this one using this formula now. We're told, according to the problem, that the triangle has an area of 36 square inches. So we know A is 36 square inches. So this becomes 36 equals 1/2. What is our base? It's x plus 6. What is our height? Our height is x. All right, so clearly, if we solve for x here, we'll know the height of this triangle. That said, we got this pesky fraction hanging out in front here. So let's go ahead and clear that by multiplying both sides of this equation by 2. This will cross out here, and 2 times 1/2 is just 1. Anything times 1 is itself, so this goes away here. But that said, we still have to work this out. 36 times 2. 6 times 2 is 12, carry a 1. 3 times 2 is 6, plus 1 is 7. So this becomes 72 equals x plus 6 times x. Let's go ahead and work this out using the distributive property. We got to take this x, we got to multiply it to this x, and then we have to multiply it to this 6. So this becomes x times x, which is x squared, plus 6 times x, which is 6x, equals 72. And at this point, you're probably saying to yourself, how am I going to solve this one for x when I have x squared, 6x, and 72? Well, if we subtract 72 from both sides, this crosses out here, leaving with 0 on this side. X squared plus 6x minus 72. And Let's go ahead and rewrite this such that the zeros on this side, this becomes x squared plus 6x minus 72 equals 0. Well, as it happens, you should be able to factor this since this is a quadratic equation that has a leading coefficient of 1. More specifically, you should be able to factor this one like this. You should be able to go x times x. Now we have to figure out two numbers that multiply to negative 72 but add to positive 6. Well, I know that 12 times negative 6 is negative 72, and similarly 12 minus 6 is positive 6. All right, so here are our two factors. But that said, we're not done yet because we have to solve these for x, which means we're going to set them both equal to 0 like this. X plus 12 equals 0, and x minus 6 equals 0. When we solve for x here, we're going to subtract 12 from both sides. This crosses out, leaving you with x equals negative 12. And to solve for x here, we're going to add 6 to both sides. My pen's starting to die here. This crosses out here, leaving you with x equals 6. Well, let's think about this. We know that the height of our triangle is x. Do you think it can be a negative value? It can, so we know that's not correct. So we know x in this case is going to be 6. So x is 6. And of course, we can see that x corresponds to the height of this triangle. So that is that one. So number 4, as you can see, says, which of the following does not represent the sides of a triangle? Well, as you may recall, we can use the side lengths and the Triangle Inequality Theorem to determine if something is a triangle or not. Specifically, the Triangle Inequality Theorem says this. If we have a triangle, and let's go ahead and quickly draw a triangle, then the sum of two of its sides always has to be greater than the third side. So if I let this side be A, this side be B, and this side be C, that means this. A plus B has to be greater than C. Likewise, A plus C has to be greater than B. And finally, B plus C has to be greater than A. If we fail to meet any of these conditions, then we do not have a triangle. So let's go ahead and apply that theorem to each of our answer choices here. And let me say this. I know this theorem so well and the math so easy to do that just by looking at the answer choices, I can tell you which of these is not a triangle. But that said, let's work out one or two of these, and then I'll explain how I quickly determine which one's not a triangle. So let's start with A here, and I'm going to make a triangle since I think it will be helpful. Again, let's call this A, this B, and this C, and let's label these correspondingly. This is A, this is B, this is C. So this is 2, this is 6, and this is 7. And let's apply these tests. Again, A plus B has to be greater than C. So 2 plus 6 has to be greater than 7. 2 plus 6 is 8. Is 8 greater than 7? It is. All right, so we passed there. Next, let's move to A plus C. So that's going to be 2 plus 7. 2 plus 7 has to be greater than B, which is 6. 2 plus 7 is 9. Is 9 greater than 6? It is. And finally, let's move on to B plus C, and that has to be greater than A. B is 6. C is 7. That has to be greater than A, which is 2. 6 plus 7 is 13, so 13 has to be greater than 2. It is. So since these side lengths all passed the Triangle Inequality Theorem, we know that A is in fact a triangle. All right, let's go ahead and move to D and test that one out. And if it's helpful, you can quickly make a triangle. And I'm going to call this A, B, and C. And let's label these accordingly. This is A, this is B, and this is C. So this is 3, 10, and 15. And let's start applying these tests here. Again, the first one is A plus B has to be greater than C. So 3 plus 10 has to be greater than 15. 3 plus 10 is 13. Is 13 greater than 15? It isn't. So this fails one of the conditions in the Triangle Inequality Theorem, and therefore I know D is not a triangle. All right. And by the way, I knew that almost immediately because I said 3 plus 10 is less than 15. It fails to meet the conditions set out by the Triangle Inequality Theorem. So again, don't be afraid to use mental math to figure these out, as long as you know that the sum of two lengths has to be greater than the third length. All right, so that is it for this video. As always, I hope you found it helpful. And as usual, you're more than welcome to leave feedback in the comment section below. In all honesty, I covered quite a few topics in this video. As a matter of fact, this is my second or third video on triangles. So if you need more help with this topic, please check out my other videos. I wouldn't be surprised if someone tries to copy this video in the near future. So just be mindful of that as well. You might get a free copy later on. If you want to help my channel out, please consider subscribing to it. And on that note, I'm going to go ahead and cut you loose.
こんにちは。